Okay, so we're going to very quickly make our way through the kidneys, and we're going to talk about some of the functions of the kidneys starting out. This is going to be in two parts. So the first part is just going to be getting to be familiar with the kidneys and the nephron, which is the functional unit. So we'll talk about the function, and really that's the regulation of extracellular fluid volume and blood pressure. So how much fluid is in your body is directly related to blood pressure. As we've mentioned before, if you put more fluid into a container that's only so big, then that's going to increase the pressure within that. And in this case, we're the container. And the more volume we have, the higher the blood pressure. That's one very simple way to look at it. And so the kidneys have the power to excrete anything else. If they don't want as much fluid, they can excrete that as urine. And that will lower the fluid volume. So that includes the extracellular fluid volume and then, of course, how that relates to blood pressure. So that means that they work kind of in concert with the cardiovascular system. And a lot of blood pressure drugs that we have are actually drugs that work on the kidney. They're things like diuretics, and a diuretic is something that makes you urinate more. So that obviously would make sense to lower fluid volume in the body, and therefore blood pressure. Now, regulation of osmolarity. Now, our cells like to be at a particular concentration. The magic number is 300 milliosmoles per liter, or milliosmolar. That's about where we want to keep things. So when we get dehydrated, this tends to start to creep up. And if we are overhydrated, this tends to creep down, and so we'll start to collect and preserve sodium and things like that. So we're trying to keep it kind of in this range within our cells, between our cells, and of course what's outside our cells, the concentration is going to be the same in both sides. One of the main things that affects osmolarity is sodium. Okay, so about 90 to 95% of our osmolarity is actually controlled by sodium. So you can imagine that the kidneys play a big role in making sure that we have the proper concentration or the proper amounts of sodium in our body. If we have too much, it will be excreted as urine, and if we don't have enough, it will be reabsorbed back into the body, as the kidneys will get that sodium, and then they'll say, wait, the body needs that, and then it will be reabsorbed back into the blood, so the body can use it to maintain fluid volume, to maintain osmolarity, and all of that good stuff. Now, another thing that happens is the regulation of pH, and it's really pretty simple the way the kidneys regulate pH. If you have a low pH, or if you have acidosis, then the kidneys will simply get rid of that. They'll simply get rid of it. We also know that buffers and respiration can control pH, but the way the kidneys do it is pretty direct. If your pH is too high or you have alkalosis, then again, your kidneys will just get rid of this bicarbonate, and then that will be excreted as urine, and that will adjust your pH. It's a little slower than the buffer, of course. The buffer is pretty immediate, and then respiration is fairly quick too. This is a little slower, but it's very direct. Okay, so that's that's an important thing that the kidneys do. And then excretion of waste. Obviously, your blood, because really what your kidneys are doing is filtering the blood, and so all of these wastes will show up in the blood, drugs will show up in the blood, and other toxins will show up in the blood. And so the kidneys, the role of the kidneys is to filter the blood. Okay, so they're constantly filtering blood. Okay, and so any of these things will then again be excreted as urine. Okay. And then the production of hormones. Now we're going to talk about that in this next section, but that's another thing that happens in the kidneys is hormonal control, hormonal production. Some hormones, obviously not all of them. The hormones are created all over the body, but the kidneys make some, and most of those are involved in something having to do with the cardiovascular system, blood pressure, something like that. Okay, so to get a good idea of the anatomy of the urinary system, most of what we're going to be talking about is what happens inside the kidney, but it helps to kind of have this backed out view so we can actually see what's going on. So we have the heart up here, and then there's the descending aorta and the abdominal aorta, and so blood goes there, and then it kind of shunts over here, and about 20 to 25% of your cardiac output will actually move into the kidneys. And then what isn't reabsorbed back into the body is then excreted through this ureter. So there's this peristaltic movement. The kidneys are constantly producing urine, and so it moves through this ureter, and then it's stored in the little for the in the urinary bladder for a little while, and it will expand and get larger and larger as it fills with urine. And then we have the micturition response, which is where urine will move out of the urethra and then to the outside world. Okay, so that's really all we're going to see of, we're just going to get closer and closer into the internal workings of the kidney, and we're going to leave all of this other stuff behind. But if we look a little closer, we can see that here's the kidney. This is the renal artery, so this is where blood is actually entering, and then that will divide into other smaller arteries, and then arterioles up here that will actually feed into something called the nephron. So if we look at this, it's just like everything else. The outer layer is the cortex, the inner layer is the medulla. The medulla starts around, these guys are called renal pyramids because they look like pyramids. Okay, so you have a whole bunch of those. And the medulla actually starts at the outer edge of these pyramids. Okay, let me maybe use a different color here. So at the outer edge of these pyramids is where the medulla starts. Okay, and that's kind of important because the concentration deep in the kidney is very high. So it has high osmolarity, so which is just high concentration. On the medulla side, so on the inside, and then out here it's a little more dilute. Okay, and that's a pretty important concept when we get to the next section, that where it's supposed to be dilute. When we get to the next section, when we actually start talking about how you either, because we know this, we either have very concentrated urine or we have very dilute urine. And it's that concentration gradient that does that. So yeah, cortex, medulla, because we're going to have these things called juxtamedullary tubules and things like that, and so it helps to know that we're talking about the medulla when we say that. Okay, and then I mentioned the pyramids, and then these arteries that are dividing will divide, and then they form something called afferent arterioles. That's going to make more sense when we actually look at those. But those afferent arterioles are going to feed into something called the nephron, and then that's going to dip down into this more concentrated area, and that's how urine's going to be made. And remember, I said kidneys get like 20 to 25%, a fourth of all the blood that's being pumped goes to the kidney. And all of that blood that goes into the kidney or into the nephrons, these guys, is on its way to being urine unless it's reabsorbed. So we're going to talk a lot about that. All right. So blood and nerve supply. As I mentioned, although the kidneys are 0.5% of the total body mass, they get 20 to 25% of the resting cardiac output. Left and right renal artery enters, branches into arteries and arterioles, and then each nephron, and this is the start of a nephron, this thing would go on, this is the proximal tubule, and then the descending loop of Henle, and then there, if we were to keep going, there would be an ascending loop and a distal tubule. Okay, but we're talking mainly about blood flow here. So each nephron receives one afferent arteriole, which is what this guy is. Okay, so this is the afferent arteriole right here. Okay, and so blood flows into that, and then it goes into something called a glomerulus, where it's filtered, and then it enters that nephron. So anything that moves into this area is on its way to becoming urine, except there's this thing called reabsorption that we'll talk about. Okay, so it divides into this big, well, not big, but a capillary ball. Okay, so that's what this is. This is a little capillary ball, and we call that a glomerulus. Okay, so that's what this thing is here. This is the glomerulus. Okay, now something very unusual happens in the kidneys, and that's on tests, and it's something that people like to talk about. But you have an afferent. Afferent means it's going to. You have an afferent arteriole. Okay. Let's see. Afferent arteriole here, which I had marked. And then it goes to a capillary. This is a capillary ball. Okay. So this glomerulus is a network of capillaries. and then it leaves to form another arteriole. Now that's unusual because we're used to going arterial, capillary, and then venule, but in this case we're not losing any oxygen. It's just being filtered, and so this is the way it goes there. Okay, so afferent, afferent arterial, capillary, and then efferent arterial. Okay. Okay, so let's see. So let's look at where we're going from there. And you can see it kind of here, this is the afferent arteriole moving in. So we're up here, afferent arteriole moving in, and then there's the glomerulus, and then you have this thing called filtration, and then the efferent here. And so it feeds into this nephron. Okay, so we have a couple of different types of nephrons. There's the cortical nephron, and then there's something called the juxtamedullary nephron, and it juxtaposes down here to the very concentrated areas and then back up. That's the loop of Henle, this part of it, okay? To the distal tubule and then to the collecting duct. So once filtrate, so filtered blood, makes it into here, then it's ultimately going to move down here, and then that's going to go to the ureter that we talked about, to the bladder, and then to the urethra to be excreted as urine. Okay, so this is the nephron. It's the microscopic functional unit of the kidney. We have like 1 million of these. Okay, so that's a lot. And that's really what the kidney is, and that's what the filtration is. That's where it takes place. Okay, so we're going to spend a lot of time talking about that. Okay, so let's look a little more closely. Afferent arteriole, and let's talk about some of the parts of it. Okay, so if we take this and we kind of unfold it so it makes a little more sense, really it loops around this way because this descending loop, or yeah, the ascending loop actually goes right past the glomerulus here through this, between this afferent and efferent arteriole. Okay, but if we unravel it, it actually makes a little more sense. It's easier to understand. So blood moves in here, and then it's filtered, and then it moves into this area, and this is called the proximal tubule. It's called proximal because it's close to this thing called the Bowman's capsule. Okay, so the Bowman's capsule is just this outer covering that surrounds the glomerulus, and the glomerulus is this little thing in here. Okay, so together that's called the renal corpuscle. I won't ask that on a test, but this entire thing is called the renal corpuscle, and then that's broken down into the Bowman's capsule, which is the outer edge, and then the inner part, which is the glomerulus. Okay, so this Bowman's capsule will actually continue to make the proximal tubule, and then you have the loop of Henle. Okay, so that's what it's called, and that's how you pronounce it, Henle. Okay, and you have the descending limb, or the descending loop of Henle, and you have the ascending limb, the ascending loop of Henle. Okay, and then you have the distal tubule. If this was proximal to the Bowman's capsule, then this is distal. Okay, so this is the distal tubule, and then you have finally the collecting duct, and the collecting duct will then drain, and that's what actually becomes urine. Okay. So if a fluid or some particle makes it through here all the way to the end without being reabsorbed, then it becomes urine. Okay, so let's look at how that happens. So I keep talking about how things go in to the afferent arteriole, and then they get filtered into the nephron, and then they can be taken back up into the blood. And see, it's because we have this blood supply all the way around this, and we call these paratubular, para means around or next to, paratubular capillaries. And so anything that we want to keep, let's say that we have glucose, and glucose will make it into the nephron, but we don't want it to go all the way through. We don't want it to turn into urine. Okay, so what happens is it can be reabsorbed into all of these blood vessels that are sitting around here, and that actually mostly takes place in the proximal tubule. We'll talk about that. Okay, so these blood vessels, and the close association of these capillaries, paratubular capillaries,